So hello everyone, welcome you all to this new video. So in my previous video, we have done with the inverter schematic using the electric binary app, okay, application. So this is a software which we use to construct the schematics and check the outputs, okay. So in the previous video, we have done. In the previous video, we have seen the schematic of inverter, okay. So in that video, I have not shown you the output about how the inverter would be looking like. So that I'm going to show you first. So see here, in the after the schematic, after the steps which I've told you, this is the output waveform which we get. Okay, in the LT-Spice software. Okay, where we have included two plots and the characteristics of an inverter. You know, right? Whatever input we give, it's opposite the output you would be producing. That is, if we give the logic is low, the output would be logic high, and vice versa. You see here, first we have logic high, that is if you consider this as logic 1, so output is 0. When it is 0, then it is 1. Okay, so these are the input and output waveforms of an inverter. Okay, so this was the schematic part. Now let us try to construct the layout of an inverter, okay, using this software only. So in order to construct the layout, the steps are: first file, new library. Okay, so then give a library name. For example, I'm giving it as inv layout, that is inverter layout. Press OK. Now cell, new cell. Now select layout and give the name as layout, since we are doing it for layout. Okay, so now see here, according to that, the components of the layout also would be getting activated. So these are the here the INV layout, the library is created. Now press Ctrl G in order to create a grid, so that in this grid we could be doing the layout. Okay. So for layout, we need to construct PMOS and NMOS transistors, right? For that, what we require one PMOS. Okay. Select the PMOS here. So this is one PMOS. And along with the PMOS, we should be having two P active regions. Okay, one is here and one is here. So we need two P active regions here. Okay, so now for this PMOS, we should be setting the width and length, that is 10 is to 2. I already told you it should be 10 is to 2. So now select this and press Ctrl J to rotate. And for these P active regions, the width we should be setting it as 10 is to 6. Okay, for both these P actives. 10 is to 6. So again rotate these, press Ctrl J. After rotating this, just align this in a single line. So now we need to be doing the connection, that is press left, right, left, right. So these are the two connections to be done. Now you should be bringing this P active as near to the PMOS transistor until we get error. Okay. So now see here, P active spacing. After some time, it would be showing it as error. At that point of time, you should be stopping it. Okay. So now see here, after 3, it is showing it as error, right? So just before error, you should be stopping it and click it, so that it would be coming near. Same goes with this here, this one. Bring it near and bring up to 3. Okay. So this is for one complete PMOS transistor. Now the setting of spice model is remaining. Okay, so now select this and press tools, simulation spice, set spice model. Okay, so now zoom this and select spice model. You see a cross mark is appearing. Click on that. So in the layout part, it's a bit difficult to select it. So it should be getting selected. Wait. So just we should be replacing that spice model as PMOS. Okay, so that I'll show you now. See here, PMOS. Okay, so now unzoom this. So this is for PMOS now. Now what I'm doing is the same thing I'm doing it for NMOS. Okay. Select NMOS transistor here. Okay, so this is that NMOS transistor. So now for this also the same thing. 10 is to 2. Select it and rotate it. And for NMOS we need to be having two N active regions. Okay. So these are the two inactive regions. Just again select this and its ratio is again keep it as 10 is to 6. Even for this one. And rotate it. So align these two now. So now after aligning again make the connections from here left click and right click, left click and left click and right click. So now again bring it together until we get the error. So see here uh, after 3 it is showing it as error. So bring up to 3. Here also same thing. So this is done now. PMOS and NMOS transistors are created. Now for VDD and ground, since we have used the PMOS transistors here, so for VDD part we should be using NWell. Okay, just opposite to that for PMOS you should be using NWell, and for ground for NMOS transistor just below that you should be using PWell. Okay, so use NWell now. Select NWell. Okay, so its size for n well should be equivalent to this connected here. So see here, this is the width, right? So this width and the width of the n well should be same. So assume it approximately as 20. If I write 20, let us see what it would be. So it is not actually exactly this. So what I'm doing is again select it and make it as 22. Okay, so now you see this width and this width is the same. Same goes for NMOS. So select N well here. So not N well, P well. Okay. Now its width you should be keeping it as the same thing 22. Okay. So these are the connections for P well and N well. So I'll just unzoom it and show it to you. So see here, okay. Now the connection part, that is the inverter. According to the inverter connection, if you compare it with the schematic, the first terminal is connected to the source part, right? So before that, we should be doing the drain to drain connection here, okay. So that I'll do it. So click here left, right. So this is one connection, and the both the gate connections, that is the input, right. You know, in order to take the common input from here, we should be taking common output, and the common input is taken by connecting the both the gates of the transistor. So connect do that as well, left and right. So along with that, we should be doing two other connections. That is, one is source to source, another one is drain to drain. So here also source to source. Okay. So these two are done. Now from here, take the common input and common output. Okay, so this is the complete inverter schematic, where this is input, this is output. Okay, so this is VDD and this is ground. So name this. In order to name it, just click it and press Control E, export. So the export characteristic, this is input, right, as I've told you in the schematic. So name it as V in. So here similarly click here, Control E. So this is output, and name it as V out. Okay, so in this way we should be constructing for the layout part. Okay, and the other thing is that putting spice code and all that remains the same. Go to components, or here miscellaneous, go to miscellaneous spice code, click click here, double click and press Control I, as I've told you in my previous video. So here, so click on multi-line text, and the spice code remains the same, which I've told you for schematic only. Okay, the same spice code, put it here. Okay, so like this spice code is created. Now check for errors, tools, DRC, check hierarchy. So they have found one error here. So let us see that where is that error. Okay. So here the error is for the minimum width. Okay. So for minimum width, what I'll do is I'll just make this as 22 is to 6 and let us check it. Okay, whether it works or not. Yeah, there are no errors now. Now check here tools, DRC, check hierarchy. So here there are no errors. So this is now error free. And like this, you should be building for layout of the inverter. Okay. So hope it is clear. And the output waveform also I have shown you it remains the same. So in this way, you should be creating a layout of a simple inverter. Also, this is just for an inverter. You could be creating for NAND gate, two input NAND gates, NOR gates, and all in this way only. Okay, where you should be considering PMOS transistors. Okay, for PMOS transistors, construct two P active regions. For NMOS transistor, construct two N active regions. Okay, so here for NMOS, I have not given the spice model. So that let us give it now. I forgot to give it. So tools, simulation spice, set spice model. Okay, so that part is not done. NMOS. Okay, so now tools, DRC, check hierarchy. So there are no errors. Okay, so in this way we should be constructing the simple inverter layout. So hope it is clear. So this was all, guys. So we'll see you in the next video with some other schematics. Okay, so that's all. Thank you.